Hello and welcome. Today I am going to explain you about evaluation of tablets. So in this lecture you will learn what are the different parameters through which we can evaluate the quality of our tablets. So basically all the parameters which can be categorized into two categories. First is official test and the second one is unofficial test. Okay, so in fact both of these are very important, but the test which are mentioned in the pharmacopoeia it is called as official, and the test which is not mentioned in pharmacopoeia it is called as unofficial test. So usually the pharmaceutical company they do all of the test, okay, but if they are doing any official test there is some criteria, some acceptance level that they have to make sure. And for the unofficial test they can make their own passing criteria or their own control. This is what is the difference between official and unofficial test. Okay, so we are going to learn them one by one, what are the different tests and what is their acceptance criteria. Okay, so first official test. In the official test we have appearance of the tablet. So we are going to see the smoothness of the tablet, texture of the tablet, it is good or bad, it is rough or smooth. So and then color also, if it is colored tablet, so color is uniform or not, is there any mottling. So this is what you are going to see in the appearance. Okay, second thing is that size and shape. So what is the size and shape of the tablet? So you are going to measure here the diameter of the tablet and thickness of the tablet. Okay, so usually it can be measured by ruler, by manual method you can use vernier calipers or screw gauge. However, there are some automatic machine also where you can measure all thickness, diameter, even weight all together by some automatic method also. Anyway, for thickness and diameter, actually the control is should be within plus minus 5%. For example, if your tablet is 100 milligram, if the tablet is 10 millimeter in the diameter or thickness, so it should be 10 millimeter plus minus 5%, like 10.5 is the higher range and 9.5 is the lower range. So any tablet is within 9.5 millimeter up to 10.5 millimeter is supposed to be good quality, and any tablet is 11 millimeter or 9 millimeter is outside of this range, so it is supposed to be bad quality. So diameter and thickness both you measure by any machine, and then you say the quality is good or bad based on their variation or deviation. If there is more deviation in any particular batch, so you are going to say that the tablet is not good quality. Usually we take 10 or 20 tablet to measure these parameters. Okay, then we have friability. The third parameter what we are going to measure is the friability of the tablet. Friability is actually the measure of loss loss in the tablet, and this is actually done a kind of predicted loss which would be there when you pack the tablet during packaging or during handling or transportation. Tablet will lose its weight. So this is what you are going to measure by this test. There is a machine called as fibrillator from several company. Roche is very classical one. Then we have Pharma test, we have Erivica. So you are going to put your tablet, usually 10 tablet or sometime the total of 10 gram tablet. You take the weight in the beginning, then put into this machine and then run it for 4 minutes with 25 revolution per minute. So the total of 100 revolution in one go. And after that you take the tablet out, de-dust means remove the particles from this tablet and measure the weight again. So then you calculate loss on the weight, loss in the weight. So this is a formula. It is called as variability or loss in the weight. Initial weight, whatever you take, like 10 gram, minus final weight after doing the procedure. What is the final weight divided by initial weight multiplied by 100. So this will give you the loss in the weight. If this loss in the weight is more than 1%, so it means that the quality of the tablet is bad. It should be within plus minus 1%. For example, if you have 99 gram after doing this procedure and it was 100 gram in the beginning you take, so it means that it is okay. Or in other words, if you take 10 gram, so it should be 9.9 gram. After doing this procedure, 9.9 gram. If there is more loss, what is mean that there is chipping is there, maybe the particles on the tablet surface is leaving the tablet. So there could be problem in your formula. There could be problem in the punching. Anything can cause loss in the train. Loss in the weight. So you have to do this to make sure that during the shelf life, during packaging, during handling, the tablet is going to be intact and it will remain, or it will contact, it will retain its quality throughout the tablet shelf life. Okay, so I will do this experiment for you. You will see the video of this experiment, how to do the variability testing of the tablet. Okay, then we have the hardness measurement. So it is actually a measure of strength of the tablet, or measure of the compactness of the tablet. Your compression force was good, your formula was good or not. So it is very, very important test. However, it is not official, but it is very important, because it can affect several things. So the tablet has to be hard enough to bear the mechanical shocks during quality control test, like size, shape and diameter and counting. So during production of the tablet itself, you take the tablet for several quality control tests. So if the tablet is not hard enough, so it can break down during the testing, so the quality is not good. For this reason, you are going to make a kind of hard tablet so that it can maintain the quality during these tests. Other processing like coloring and coating. If you are going to have a colored tablet or coated tablet, then also the tablet is not very hard or not hard enough. So during these processes, the tablet can break down easily. So it is very important that you have a sufficiently hard tablet to bear all of these processing parameters. During packaging or during handling, during transportation, and during shelf life, if the shelf life of tablet is 3 years, so it has to be very hard enough to remain intact throughout its shelf life. Okay, so usually we measure the hardness by hardness tester. It may be manual or it may be automatic also. There are so many hardness tester manual, like Monsanto, Pfizer, Irvika, Okay, so you put your tablet there and then apply the force. It is measured actually in the term of force, and the normal range of tablet, is like 5 to 10 kilogram, or it is like 50 to 100 Newton. So usually Newton and or kilogram is the commonest unit. However, there are several other units also. So usually depend on the type of tablet. As you know, there are several kind of tablet. So hardness of the tablet is not uniform, or not like you don't have any kind of particular range. Soluble tablet, dispersible tablet, they could be less hard, uh, you know, immediate release tablet, they could be even harder than the soluble tablet. And if you have something modified release tablet, they may be even more harder than the conventional release tablet. So hardness is dependent on the type of tablet, and usually the range is 5 to 10 kilogram, or a maximum up to 20 kilogram. Okay, or even it can be less also. In the case of soluble tablet, it may be 2 or 3 kilogram only. Okay, so these are all kind of unofficial tests. So we have four very common official tests: disintegration, dissolution, weight variation, and content uniformity. So disintegration is a test where you want to measure the time it takes to disintegrate in the stomach. If you take the tablet, how long it will take to break down actually. The whole tablet will disintegrate in the particles or in the granules. Later on it will dissolve. So you measure simply the time only to break down, nothing else. So it is very simple test. There is disintegration machine. You put 6 tablets there and you measure the time to break down. There is a screen. You see that there is nothing on the screen after the test is finished. Usually the time limit for this test is 15 to 30 minutes, sometimes even more. It depends on the type of tablet, and also depends on the country to country. It is something different also. But usually for normal tablet it is 15 minutes. Okay, should disintegrate within 15 minutes or 30 minutes. Okay, normal tablet 15 minutes, and coated tablet like film coated or sugar coated within 30 minutes. Okay, if you have entry coated tablet, so it will take more time, and you are going to use 2 different media, HCl first, and then you replace the HCl and put it into the phosphate buffer. Otherwise, normally you take just one media, HCl or water even can be taken. Okay, so these tests you are going to take in the next level. Dissolution is a process of measurement of the release of the tablet, release of the material from the tablet. So it is a kind of rate process. You put your tablet in the dissolution machine and you measure that how the drug is releasing with the time. So you make a kind of time and concentration profile of your tablet, and it is actually a kind of measure of absorption, or it is a kind of performance evaluation. If the tablet is belonging to very highly soluble and highly dissolution tablet, so it will simply dissolve within half hour. You can see something 80 or 85% dissolve in half hour for the immediate release dosage form. If it is modified release dosage form, so it can take longer and it dissolves slowly, but still you need to do this, and you want to prepare a kind of dissolution profile, how well it is releasing over the time period which is mentioned. If the tablet is once a day, so you need to do the dissolution for at least 12 hour or 24 hour. If it is immediate release, so you do the dissolution until it is completely dissolved, usually up to 2 hours maximum. Okay, so dissolution for immediate release, more than 95% release is there within 30 minutes. Then we have third test, which is weight variation, and the fourth one is content uniformity. Both of these tests, these are a part of uniformity of the doses. You prepare a tablet, the tablet is uniform, is not or not. You are going to do this by weight variation and content uniformity. Weight variation is a level 1 test. If actually tablet is larger in the size, so you can rely on the weight variation only. If the tablet is a smaller size or the content inside the tablet is 25% and the remaining is excipient, so in that case you need to do the content uniformity also. So for weight variation, it is a very simple test. You are going to take 20 tablet and measure the weight of tablet individually, and then find out the average weight of all 20 tablets. Then apply this formula to find out the deviation or change in the weight per tablet. So for every tablet you are going to find out this. For example, you have 20 tablets, so weight of the tablet number 1 individual weight of one tablet minus average weight of all 20 tablets divided by average weight, multiply by 100. This will give you deviation for tablet number 1. Likewise, you are going to do for tablet number 2 and 3 and so on up to all 20 tablets. So if all the tablet is within this range plus minus 10%, so you can say that the weight variation is passed and your tablet is very good quality and there is not more weight variation. Ideally there should be no weight variation. If you are going to prepare 100 gram tablets, so all the tablets should be 100 milligram. So all the tablets should be 100 milligram, but in fact it is very unlikely that you have all the tablet 100 milligram, because the material you are not going to put into the tablet machine by measurement. It is by 12 size, so it may be more or less. It may be rather than 100, it may be 110 or it may be 90. That is why you are going to make sure that the deviation is there, but it is within the range. So plus minus 10% is actually allowed, and there are even more percentage based on the size of tablet. For a smaller tablet you have more flexibility, more deviation is allowed. For larger tablet, even less deviation is allowed, like 5% or 7.5% is allowed. So for example, if you have a 100 milligram tablet, so 90 milligram tablet up to 110 milligram tablet is okay. You can say the weight is uniform. Okay, it should be 100, but even 90 milligram or 110 milligram or within this range, any tablet you can say weight is uniform. Okay, so this is the purpose of this test, that you want to make sure that the quality of tablet is good and the weight is almost uniform. Okay, then we have the last test is content uniformity. And what is this actually? What is the difference between this one and this one? Here you measure the whole content. The total content of the tablet is measured by weighing machine. But here your concern is the API only. You are going to measure the API in the tablet. If you have a tablet of 500 milligram, your main concern is the API only. For example, in 500 milligram tablet, if the actual API is 100 milligram and remaining is excipient, so you are going to measure the API only 100 milligram API is in every tablet is reported, or theoretical amount is 100 milligram. So you are going to use UV or HPLC is a kind of analytical tool to find out the amount of API in every tablet. So you take some 10 or 20 tablet and dissolve them individually in the solvent, and then find out the content or find out the API in all tablet, and then you apply the formula. It is almost same formula, so you are going to see the deviation in every tablet, and the deviation should not be more than plus minus 15%. If your API is 100 milligram in all tablet, so any tablet with 85 milligram the minimum amount, and with 115 milligram the highest amount is supposed to be good quality. The content is uniform. Any tablet is more amount 120 milligram, or any tablet with less than 85, like 80 milligram, is supposed to be outside of this range, and it is not good quality. So both of these tests, content uniformity and weight variation, both of these are measure of the uniformity of the doses. If anything is not passing, or it is failing, so it will lead to serious consequences. The variation in the weight or variation in the content may lead to differences in the dose. Dose variation may be there, and it can maybe toxic sometime if the drug is narrow therapeutic index, or it may lead to like no effect if it is large therapeutic index, so it may be subtherapeutic if the variation is on the lower side. Okay, so these are some quality parameter. You are going to do this. Some of the tests we are going to do in our lab here, which is possible, and other tests we will do in the next level. Thank you.